Hi, my name is Nathanit, and in this video, I'm going to walk you through a very brief introduction to machine translation and its applications. So before we begin, here are things that you need to know about this video and about getting started with machine translation in general, so that you will not be stuck in the confusion like where is that from and where is this from, something like that. So first, machine translation is tightly involved with machine learning. And that's because machine translation uses the technology for machine learning. This means that you need to have a basic understanding of machine learning first. You will definitely hear the machine learning related terms in this video, and here is the list of them. If you haven't heard about these terms before, that's okay. You can pause here and search it up first before you continue with this video. And if you are very new to this whole machine learning business, I recommend you to watch A Gentle Introduction to Machine Learning by StatQuest. That video will guide you through the concept of machine learning with a very easy example. Okay, so let's move into our first topic. What is machine translation? So let's talk about translation in general first. To put it simply, translation is the process of transferring the meaning of text from one language to another. It's what people have been doing and dealing with for a very long time. Like we have the Greek translation of Hebrew Bible since the 3rd century BC. We have first English translation of Kama Sutra in 1883, even though it was illegal at the time. Or we have Harry Potter books in various languages in our present day, and so on. So translation is not a new thing at all. And as we have seen many people devote their life practicing it, we should know at this point that translation is, in fact, a difficult and complicated process. As people study more about translation, they also develop technologies to make translation easier, and of course, machine translation is one of them. So what exactly is machine translation? Machine translation is a technology that uses software to perform a translation without human involvement. It can be a translation of any kind of input to any kind of output, such as from text to text or from text to speech, and vice versa. Even though it's a process without human involvement, it may still require humans to review or validate the translation result anyway, because most of the time, the result from the software does need a lot of adjustment. At this point, we might have a question like, wait a minute, if we still need someone to check the translation result, why don't we just hire people to translate the whole thing in the first place? Well, that's because translation by humans takes time. Quite a lot of time actually, depending on the content of text or the document. So we want to use the computational resources of a machine to speed up the whole process. It's like we use a machine to generate a rough translation for us first, something like that. Using a machine is also more convenient than hiring a translator in some cases. For example, if you just want to translate this little tiny English sentence to, let's say, Thai language, which is my native language, hiring a translator to translate just this one sentence is a bit too much work, obviously. So now let's talk about how machine learning gets involved in this machine translation business. The difficult task that machine translation is dealing with is the ubiquity and the flexibility of human language. You might notice that the language we use in real life doesn't really follow grammar rules. For example, in Thai language, if you want to ask your friend whether they have had lunch or not, you may ask, or you may say, กินข้าวยัง instead of following the grammar rules and say คุณกินข้าวกลางวันแล้วหรือยัง something like that. When we implement a translation system, we need a specific instruction of how this particular sentence can be translated into another language, right? But language is dynamic. It always changes every now and then, which means that handling everything in advance is impossible. So we need to put the intelligence to the machine so that it can learn and find a solution of the problem by itself, like what us the human can do. And machine learning is exactly about that, about how we can put the intelligence to the machine. This is the reason why machine learning plays an important role in many machine translation approaches, and I will talk about those approaches soon in the later section. Now, let's see how can we use machine translation. Firstly, we can use it to create a translation service or application. Create a service like Google Translate or Microsoft Translator, but in your own version. We can also create an application that targets only at some specific domain. For example, if you create an application for a law firm, your application might focus mainly on translating legal documents or legal terms, something like that. Or we can adopt machine translation to add language feature or translation feature to your application. For example, you might use it to provide instant translation for your web content. Or you can make a translator device for real-time speech-to-speech translation, and so on. It can be anything translation related, really. So we reach our last topic, machine translation approaches. There are 4 approaches in machine translation. Since each approach has its own requirements and limitations, you need to be aware that not all the approaches are suitable for solving your problem. Some approaches may give better results than others in some particular cases, so you really need to understand the difference between them and choose what you think is the most suitable approach for your case. From my personal experience, what helps me choose is the requirements of each approach, because unfortunately I don't have enough resources to try another approach other than rule-based approach. Another way to know which one to choose is reading research papers. There are many people out there conducting research about machine translation, so you will gain a lot of knowledge from their work. So let's talk about the first approach, rule-based machine translation. Rule-based machine translation is the oldest and classic approach of machine translation. It uses the linguistic rules to translate the source language to the target language. What this approach requires are, first, the linguistic rules for both source and target languages, and second, the bilingual dictionary, because this approach is basically converting linguistic rules to a code. So you need a deep understanding of both source and target languages in order to code that. For example, if you want to translate English text to Thai text, you need to know both English grammar and Thai grammar, like how the sentence is arranged in each language, or how parts of speech works in each language, etc. Bilingual dictionary is also required because you also need to map words from the source language to the target language. It's like you need a dictionary to look up words in another language, something like that. You can say that this approach is an expert system of machine translation. And actually, this approach can be divided into 3 sub-approaches, but I will not focus on their details and just gonna leave the name here in case you want to search for them later. The next approach, statistical machine translation, is an approach that uses a statistical model to predict the translation text. So now, instead of writing rules by yourself like a previous approach, we use a statistical model to choose the translation text that has the highest probability of being the translated text of the given source text. The statistical model is created by analyzing the existing translation text in the bilingual corpus, and we can use like Bayes' theorem or hidden Markov model to create this statistical model. This approach doesn't require linguistic knowledge because we let the model learn and figure everything out from the data. And since a statistical model only learns from the data, we really need a large amount of data to make sure that the model knows all possible translations as much as possible. So what this approach requires are, first, a very large bilingual text corpus, and second, a computer with a high performance to train a statistical model. This is an example of bilingual corpus. You can see that we have both English sentence and its associated sentence in Spanish. And we can use this data to train a model. And by very large corpus, I mean that the corpus should contain at least hundreds of sentences, because we don't want the model to translate a word dog in English to a word male in Thai, because our corpus only have like 10 sentences that don't say anything about dog is equivalent to ma, right? So the variety and amount of sentences in a corpus is very important. And since we are dealing with a very large bilingual corpus here, we really need a high performance computer to work with a corpus and train a model. We surely don't want our computer to stop responding every time we train a model. That would be troublesome. And for the record, Google Translate also used this approach until 2016. Currently, they have already transferred their system to use neural machine translation approach instead. The next approach is example-based machine translation. The concept of this approach is translation by analogy. It means that you know how to translate a particular sentence because you have translated similar sentences before. It's like you can make a new sentence by imitating the sentence you have already known. And in this case, what the system have already known is the sentence from the corpus. And that's why we call it example-based translation. So where's this concept from? This concept is based on the ideas suggested by Makoto Nagao in 1984. Here's the full quote of the said ideas. And in summary, these ideas state that normally, people don't translate a sentence by analyzing its linguistic properties. Instead, they translate a sentence phrase by phrase with their knowledge gained from the example translations. This approach is mostly used for translating a language pair that has different sentence structures, such as translating English to Japanese. Well, because English has word order like subject, verb, object, but Japanese has like subject, object, verb. This is actually based on the assumption that the sentence structure of the source language has nothing to do with the structure of the sentence in the target language. Let's look at the example here from Sato and Nagao in 1990 from two-word memory-based translation paper. Suppose we want to translate this English sentence. He buys a book on international politics to the Japanese language. With this approach, the system will look at the bilingual corpus and find a sentence that is similar to the source sentence. In this case, it finds this sentence. He buys a notebook. And the translation text of this sentence is Kare wa noto o kau. So now we know that this first part of the sentence can be translated into this part, Kare wa ... o kau. But we still don't know about this the book on international politics part, right? So the system looks at the corpus again and finds this sentence. I read a book on international politics, and now the system knows that a book on international politics is equivalent to Kokusai seiji ni suite kakareta hon. Then the system combines these two parts together and we get this sentence as a result. Kare wa kokusai seiji ni suite kakareta hon o kau. Okay, before we move on, please note that the process of matching the input sentence with the example in the corpus can be varied. We can match them by characters, by word, or by phrase. It really depends on how you want to approach this. And let me tell you that this is not an easy process either. Because, well, how you gonna know that these text match those texts. So for this approach, what it requires is just a bilingual corpus, and the larger the corpus is, the better the translation we can get. Last but not least, neural machine translation. This approach is similar to the statistical approach, but instead of using a probability distribution, it uses a neural network to predict the most suitable translation text. This is where we adopt machine learning techniques like neural networks into machine translation. The neural network in this case can be something like recurrent neural network or long short-term memory, which is used by Google Translate, by the way. And usually it will be a neural network that works with sequential data, because we are dealing with the text data here, and text data is sequential data. So now with this approach, we will have only one model that handles the end-to-end translation process. There is no need to use a pipeline that consists of many subcomponents anymore, because everything is handled automatically by a neural network. So the system structure of neural machine translation will be much simpler than statistical machine translation. For this approach, it requires the same things as in statistical approach, and those things are: first, a very large bilingual text corpus, and second, a high-performance computer to train a model. Actually, at the time when I made this video, we already have a service like Google Colab, which enables us to train a neural network easily without suffering from the setup process. So this high-performance computer requirement may not be that necessary anymore. But the size and the variation of bilingual corpus is still very important here, because training a neural network usually requires a large amount of data. Like, we need a training dataset for training a model, we need a validation dataset for tuning a model, we also need a test dataset for testing the whole thing, because we don't want our model to be overfitting, we don't want it to be very good at predicting the training data and really bad at predicting the real world data, and so on. If you have trained models in machine learning before, you will get what I mean. But if you haven't, just keep in mind that it's a lot of data. And for those who are interested in how Google Translate implements this approach, you can find more details in this paper, and I will put the link in the description below. So that's it. This is the end of the video now. I hope this video helps you understand what machine translation is in general. Or if you are still confused about this whole thing, at least I hope you know the keyword to search for. So thank you for listening.